Hello, everyone. Good morning, good afternoon, good evening to all of you. So, here I am, Santosh Mudol. I will be the host for this talk. I will be there throughout the talk. Our next talk will be on source versus binary code analysis, challenges and solutions within the software supply chain. So, this presentation mainly explores different complexities and best practices in vulnerability management within automotive supply chain, mainly focusing on challenges in complex software handling, including open source components, third party libraries, and proprietary softwares. In addition to this, the role of vulnerability disclosure reports, the VDRs, and vulnerability exploitability exchange VEX in providing a robust foundation for effective vulnerability management. So at the end of this session, we'll also have a Q&A for the last few minutes. Please feel free to post your questions in the Q&A tab in advance so that we can answer them one by one. So here for this presentation, we have Irina Kimmel, who is a project manager for automotive vulnerability management at ETAS GmbH. She comes with a strong background in offensive security and possesses an extensive experience in SBOM management. So all of you, please join me in welcoming Ms. Irina Kimmel to the stage. So Irina, stage is yours. Please, uh,
Yeah,
we
thank
are
you so
waiting for
much.
your presentation.
Perfect. Thank you so much. Hello, everyone. Thank you for joining my session today to discuss the challenges and the solutions around source code and binary code analyzing within software supply chain. Before we dive in, let me briefly introduce myself. So my name is Irina Kimmel. Like in the introduction, I'm the product manager for automotive vulnerability management, and I'm at ETA since 2017. So I have a really strong background in IT security, from system integration to architecture, leading a pen testing team, and now focusing on the automotive market. Um, my experience has given me a unique perspective from various sections, the complexity, and of course, a lot of insights in vulnerability management. Um, then some fun facts about me. I have two cats. I love playing table tennis and do some gym and travel a lot around the world. Let's have a quick look to our agenda today. So we will start by looking at the current challenges, then dive into source code and binary code analysis, see how automation helps us, and finally wrap up with some key recommendations also from my side. Let's begin with setting the context with the challenges we face currently in the software supply chain. So currently we have, of course, an increased complexity within a software, especially in the automotive industry. So let's break down what that look like during the development lifecycle. So on the slide, you see a simple product development lifecycle. So we will look at it from a security perspective. So security and especially vulnerability management can be found during the design and development of a product or after a final product release. So if we look to design and development, then the focus or the strong focus is more on security testing, including verification validation, vulnerability management. And if we look at post-production released products that are already in a vehicle, we have a strong focus on keeping the vulnerabilities, manage them, and fast react and be prepared for incident response. So important is to establish a real-time continuous monitoring for complete product development lifecycle. You can see on this slide how a final product can be look like, because we have a mix of different codes. So looking to an example of ECU, you can have code that you write by yourself. It can be proprietary code. For example, we at ETAS writing AUTOSAR software, RTR car, for example, what is a basic proprietary software. give it to OEMs. They include their own code in top of it. Sometimes in a software, there are a lot of open source components that can be used or third-party libraries. And each of these kind of code will be developed. After that, there are a lot of testing methodologies or testing strategies with different verification, validation, static analysis, dynamic analysis, etc. So I also exclude penetration test or anything else like in the design, threat, and risk analysis. So you see there's a complex and diverse software, and we have some key pain points there. So one of the key pain points we have is the product are really, really unique and different. We have different license, we have different versions, and developers are also a lot of different teams. So you can have for one product different teams, or you have for each product different development teams, depending on the size of your company and how you build up your structure. What you also can see in some product development is that you have, of course, different updates, different release cycles, PI plannings, and of course, testing a software is also really unique and diverse. So you can have different tools for testing all these code, and you can have different strategies. So that means at the end you have products with different qualities, with various version, with various test results. And then of course at the end we have a final product and a really nice car. So great. I already mentioned some pain points during the product lifecycle, but let's have a look, and I will give you some pain points on impact and quality regarding vulnerability management of these products. At the moment, there are a lot of new regulations which required a comprehensive vulnerability management system because of rapid response to vulnerabilities due to rapid threat landscape. Because every day or every month, new vulnerabilities can appear. Let's understand the key pain points we have in this context. Currently, the first step is, of course, I mentioned it, the complexity, the diversity of code and product and software. And we miss maybe the transparency of our product because everyone has their own strategy to create an ASBOM, for example, or have or how they use a complete list of the product and have a full picture of the complete fleet or a vehicle, because in a vehicle you have really unique different ECUs. Without a full list, it's really, really difficult to gain the visibility of vulnerabilities because we need to understand the components in the software to map it later to vulnerabilities. So then, of course, to handling vulnerabilities, we need to fulfill some controls, and maybe we could miss some blind spot. We miss some controls because if we don't have the full picture, maybe we can't build a clear risk assessment or vulnerability management and handling vulnerabilities. So at the end, we will also have a really big pressure on fixing vulnerabilities. So now it's time to solve exactly these key points step by step. And let's start with having a look to the complex, diverse software. So I will show you here in this slide the first step. We need to understand how an ECU, for example, look like. So on the one hand, we have, of course, the source code, and on the other hand, the binary code. What does it mean? So if we use the example ECU, you need to understand ECUs run on binary code, not on source code. So I spoke with a lot of customers. They told me they have in-house development teams. They create their own ECU firmware images. They know exactly the code. They use the codes to compile everything, create the firmware image, flash the image to the ECU in the car, and then everything is ready. I spoke also with customer. They not only take care of all the ECUs that they are developed, they're also using and buying third-party ECUs from different vendors. But there, of course, we have a problem. We don't know what is exactly in this third-party ECU. And then there's also a group of customers who don't have an in-house development team. They normally build complete vehicle with buying ECUs, with both ECUs. So they integrate each ECU in a vehicle, and then on a later point, they need to make sure and they are responsible that the complete vehicle is protected and that you have a good vulnerability management for your complete vehicle and fleet and take care of everything you have in your vehicle. And the key pain point here is the transparency. With in-house development, you have, on the one hand, transparency because you know the code, you can create your SBOM from this kind of code, and on the other hand, you don't have the access to the code because ECUs run on binary, and binary normally don't have, or you not in every case you will receive an SBOM from it. So first step is of course gaining transparency where we don't have it. So we need software bill of material of all ECUs we integrate in our vehicle for a full picture. So for all of you who are not really familiar with the wording SBOM, short break and recap. SBOM is a formal machine readable ingredient list. So you know exactly with this kind of list what you have inside your product, whether there's open source, proprietary, or third-party libraries. So what you also have with this information, the source code information, or like the dependencies, the version, the manufacturer who's responsible. And of course, it's a machine readable, normally file, or it should be by using standards like CycloneDX and SPDX. So I always recommend to use standards and also structured ways, because if you don't have good quality SBOM, you maybe miss some hidden points. So now you understand, of course, how a SBOM looks like. Going to the next step, understand how we can create them. So here's an example how, or in a simple way, how you can create an SBOM. If, like the example I told you, the in-house development, they have the metadata, they have exactly everything they need, the source code, etc., to create the SBOM. So you need input information to create a complete list. This is only possible if you have the information. And on the other hand, if you don't have the information, you can create an SBOM, or now it's possible with some various tools that you create out of a binary file automatically a software bill of material. So for example, we at ETAS using the tool Wonky to create SBOM, but of course, if you are using your own way, it's totally fine. The only thing is where I say I would recommend you, if you do it partially automated or not automated, it's always better to do it in an automated way to make the work for you easier and that you make sure everything works fine. In this scenario, of course, there's also a possibility. If you already have both possibilities, you have the binary code and you have the source code and metadata, you can, of course, use both information and make your own SBOM as a good state of the art. So it's always depending on the sources you have. This difference between the source and binary code and on the topic SBOM is really crucial, because SBOM is really needed to map later vulnerabilities to specific components. So let's explore a little bit in detail how we analyze the SBOM with the various analyzing methods. Because in my session, I wanted to introduce you the source code and binary code analyzing. So we have two primary methods for understanding our software composition: source code and binary code. And we have source code analyzing and binary code analyzing. So let's deep dive the difference of the analyzes. So in this table, I highlighted some key difference. I already mentioned that the use case is, of course, for both scenario a little bit different. On the one hand, you have, of course, the in-house development, and on the other hand, you're just purchasing some ECUs. So you should take care on the limitation of the code. If you're just looking on open source components, then of course source code analyzing is really easy. If you handle third-party or proprietary software, then of course you are on the limit of source code analyzing, because you don't have the possibilities to scan really deeply IoT devices or AUTOSAR components. So that's why binary code is here the better tool for it. So important is also the input of SBOM. For example, software code analyzing are tools like FOSSA or dependency track. For these kind of tools and detecting vulnerabilities, you need as input already a created SBOM. In case of binary code analyzing, you don't need it, but it's possible to upload it as well. So there is a possibility in a binary code tool that you can upload a SBOM, but if you don't have it, we want to create some, because we need at the end to see exactly what is in our software to have the visibility of vulnerabilities. So that's why taking care which kind of method you use, it's just step by step. To find vulnerabilities, the source of vulnerability is also really important, because on the one hand, like I mentioned, FOSSA or dependency track are focusing on public vulnerability database. It's totally fine, because binary code tools like we use, Wonky, is also completely using the same database. The only thing that we need later is, of course, a possibility to integrate additional databases, because in the automotive industry, we have different components, really specific automotive. For example, we analyzed RTR car to create the SBOM. What we currently can do is, of course, map them to known vulnerabilities, because there are no known vulnerabilities, and we need to integrate internal databases to map it to vulnerabilities, because if you don't have one, you will not find anything. So, but this difference don't stop in this table. So I bring you also a different overview. So you see also on these examples with the specific buzzwords that the source code analyzing is shining during the development and build time. So giving a precise deprecated visibility into dependencies before deployment. It catches logical flaws or obvious vulnerabilities. It protects against developer mistakes or design flaws. Binary code analyzing is more looking at post-build. So it shines especially where source is unavailable and if you have runtime behavior. So that means you have a firmware, this firmware, or a firmware in an ECU. This ECU should also work with other ECUs. So you have complete different dependencies in comparison to you develop something and have dependencies during your development. So it from the perspective of binary code analyzing, it catch compiled level issues, use them dynamically analyzes to detect hidden components and dependencies. It protects also against supply chain attack, compiler bugs, runtime exploits. It can also, depending on the tool you use, additional issues like hard-coded passwords or any zero-day, or if there's unwanted software in your software, because I saw various results on it. Let's have a look to some examples, because I bring you an example for Log4Shell. Log4Shell is an exploits, or Log4Shell exploits Java naming and directory interface, so allowing remote code execution via malicious LDP DNS lookup. So we see there is a limitation of source code analyzing if we analyze the software just with this kind of method. By detecting of runtime exploits, there is a limitation because we can't see it, because final product have runtime dependencies, not during the development. And we would miss obfuscated or compiled vulnerabilities. And the binary code limitation were on data flows, and we miss the context about exploitability because we need the source code. So combining these two approaches improved the defense. So you would use source code analyzing to find vulnerable code pattern. And with binary analysis, you would detect, for example, Log4j in a vehicle component. So, and this can happen in vehicle telematics gateway, in OTA update services, in vehicle infotainment systems, Android automotive libraries, etc. I have a second example for you. So Heartbleed. Heartbleed exploits a buffer overflow overread vulnerability in OpenSSL. So TLS Heartbleed extension allows attacker to read up to 64 kilobytes of memory from a server, potentially exposing private keys, password-sensitive data. We see here also, again, limitation in source code analyzing by detecting, again, runtime vulnerabilities and would miss dynamic linked vulnerabilities. And on the other hand, binary code limitation where on data sensitivity context and missing source level security pattern. So again, if we combine both approach for defense, then source code analyzing would find vulnerabilities of OpenSSL using pattern, and binary analysis would detect libraries in all vehicles and the vulnerable libraries. So let's have a look what we saw. So on the example, we saw that one analyzing method not provide a complete coverage of all vulnerabilities in a product. Each methods find critical issues that the other miss. A combined analyzing provides you defense in depth and a complete transparency. And this is really, really important and urgent. And I talked a lot about real examples of vulnerabilities, but I missed to show you how we detect and map from SBOM. So let's dive in the detection of vulnerabilities and continuous monitoring. So let's have a quick look how this process looks like in a nutshell. And our vulnerability management system takes product information as input. So on the left side, we see the input files. It can be a binary file to create automatically an SBOM, or you have already an SBOM. So this kind of input you need in a vulnerability management system to scan and see all vulnerabilities. Important is that the components are listed, because a vulnerability management tool or like a vulnerability scanner is mapping common platform enumeration indicator. It is an industry standard, and map component names to specific vulnerabilities to give you at the end a complete list and overview of all vulnerabilities that you have in your software, in your product. And then you can create reports and all known vulnerabilities that are affected. So keep in mind, or like I mentioned it before, there are possibilities to use self-created SBOM that is related to a final product image. And what you also can do is use this self-created SBOM, use your final binary image, upload both to validate and have a complete picture of both. Because it can happen that you miss some components, and at the end you want, of course, see everything, or we as security guys want to see everything. So that's why my passion is your passion. Or what you also can do is, of course, upload different binary files with different kind of version and compare each other. So this is also a possibility. So great. Now we all understand the process in a nutshell. And this is the start of the really fun work, or I would say my fun work, because I'm a security guy. We gain visibility of vulnerabilities, and we need to jump to action. Because, of course, just finding vulnerabilities is easy. but managing vulnerabilities, this is hard work. So the first step is, of course, we discover all components. We scan for vulnerabilities, and now we get a huge list of vulnerabilities depending on your software and the complexity of your software. Because I saw software infotainment system with, I would say, 5,000 vulnerabilities. Sometimes it's smaller, like 1,000, depending on how you write your code. And of course, the size and the numbers of vulnerability depending also on the quality of code that you write, or if you already implement security measures. So how we want to handle and prioritize these kind of vulnerabilities is the next step, and prepare the mitigation measure. We need, first of all, to understand and answer some questions. So we need to understand, are we really need to fix vulnerabilities because we have the huge number? What is, of course, the damage scenario? If someone exploits some vulnerabilities, we need to understand until when we should fix everything, and how does this fit to our release schedule, and what is the impact of the vulnerabilities on our product. So these are a lot of questions. And if you are here and you say, okay, I can't answer any question and I have trouble to answer all this question, don't worry. You can always reach ETAS. Our security experts could help you, could support you, and we have enterprise and automotive knowledge. So you don't need to do it by yourself. You can also ask for help. Some question will also arise when you use third-party components, because we have, if we use both methods, different kind of vulnerabilities. And then we have, like I mentioned in the beginning, different kind of components, like third-party AutoSAR components, or third-party vendors, third-party libraries. And to answer the question how this vulnerability can exploit, this is something you can't handle by yourself. You need to contact the vendor to ask for specific statements or find out if there are fixes already in place, in progress, etc. So here we need additional information to manage and address all these vulnerabilities. And this is the point where automation and a foundation makes sense and come in. So let's have a look. What does it mean? So first of all, we got transparency of our product. We know exactly what is inside. We gain visibility of all vulnerabilities we have, and now we need to answer all the questions. So we should find a way to become more efficient, react fast, automate everything, that we have a really good, efficient vulnerability management. Because if you don't do it, you spend a lot of time, lose money, everything is manually, you guess some works, and then of course you're really slow in response time and you struggle maybe to collaborate with different teams. So let's deep dive in the foundation and the standards that can help you to exactly answer some questions. In the vulnerability management context, there are, of course, a lot of questions. So we start, of course, in the beginning, standardize of SBOM. We know what is inside our product and we create it automatically, in best case with CycloneDX or SPDX within standard format. So the next step is we have the vulnerability disclosure report. That means we have we made it visible that what vulnerabilities we have, and we know them because we scan the SBOM against databases and get a list of vulnerabilities. So we know exactly which kind of CVEs we have, and now we need to answer exactly the question what I mentioned before. We can use vulnerability exploitability exchange, the WEX file. So we need now to try to understand if our product is really affected or vulnerable to specific vulnerabilities by answering some question. Because some question or some components are affected by CVEs doesn't mean really your product is vulnerable, because they need sometimes you need some how to say it, some definition, or not definitions, but some conditions that you can exploit it, because just to have a vulnerability doesn't mean, oh, I'm get hacked. So like I mentioned in the previous, we can also have some CVEs that are related to third-party vendors. And that's why WAX is a really supporting option here. So with WAX, WAX support you to that you can download an systematic file from your scanning algorithm. You can send it to your vendors, ask for a statement that they can give you, and then you can upload it in your management system. So the statement could be a CVE is exploitable in a specific component like Linux kernel, or there are already mitigation measures in place, or patches are in progress. So that's why it's really, really important. And the last point is CSAF. So with CSAF, you can improve the foundation, and vendors can publish machine readable alerts that you can use and check if your software is vulnerable of it. So in best case, your tool provides APIs. You can, of course, use this machine readable alerts, check it against your vulnerabilities, and make your progress and mitigation measures faster. Great, coming to the end. So I would say the foundation and the automation is really, really clear. We are good to go. During my speak, I already give you some recommendation, but let's recap and summarize what you hear today. So you learned today that we need gain transparency through SBOMs. So you need to understand that SBOM is the basis for detecting vulnerabilities. It doesn't matter which kind of code you use. My recommendation to you is to use standardized formats. Creating them automatically is the best case to have a whole picture and to make you faster. And you understand now the difference of source code and binary code and the analysis techniques, and the benefits for combining both for defense and depth. My recommendation would be reduce blind spots in your software supply chain by using both techniques, because it's important to have a secure product. You learned also the foundation at the end for efficient and standardization to automate your vulnerability process, to be faster, to rapid incident response, reduce reaction emergency path. And my recommendation would be, it is never too late to using standards and APIs. And you learned also to fostering culture of security through the entire product lifecycle, because you listen to my speak. And it's always important to build up security products. So from design and development to post-product and releases. So my recommendation, if you need support in each single step, you can always contact ETAS, and we can support you with consulting services or tools if you need any advice for it. So that's all from my side. So thank you very much for your attention. And I would be happy to catch all your questions that someone have. And afterwards, I will stop, not stop, I will say on the next slide, you will get my contact information. And if you would like to connect, yeah, please feel free and visit our website. So thank you so much.
Thank you very much, Irina. It was very nice presentation. So perfect. So we're on time, and we have some time for Q&A session. So let's look at the questions which are there in the Q&A. I will put the questions on the screen. So the first one, what is your experience of quality of SBOMs which are generated from binary scan tools?
Yeah, so if this, like if you have code open source, it's really, really good. Everything that is open source, the creation from binary scanning tools is really good, and really, like I would say, 90% of every component can be detected depending on the tool. So this is one step. But if you try to detect really AUTOSAR specific components, then there's of course a limitation. And my experience is, of course, for binary code, for binary scanning tools, the architecture or understanding the architecture is important. But detecting AUTOSAR files and create SBOM from AUTOSAR files, it's possible. If a tool cannot support it, they can learn it, because then AI comes in game. So of course, it's like we give input about the architecture and the tool can improve to analyze and create a better SBOM. So I would say for open source, really, really good quality. For everything that is own written, proprietary, third party, it can have limitations.
Okay, perfect. Thank you for the answer. So coming up next, the next question will be this one. Do you have, I think it goes in a similar direction of what you asked or what you explained before. Do you have
Yes.
any tools which are detecting the embedded codes like AUTOSAR, AUTOSAR? Any
Yes, of
known
course we
tools?
have. I also saw some other tools, like we are cooperating with Wonky together, so I can be sure we can do it because we detect our own software. So that's why I can't be sure. I saw also some other binary code analyzing tools. They also support it. So there are of course possible ways to detect them.
Okay, perfect. Thank you. So coming up next is the question, can you mention some of the tools which you
Oh,
know
of
which are
course.
open source for this, for a binary
Yes.
code?
For binary code, I need to relook it. I don't have the names for open source tools. I only know the name who are like, charging.
Commercial. Yeah,
Yeah,
the commercial
so
tools.
for open source, I need to look it, but I know 2 examples, but I don't have currently exactly the names in mind. But if you want to know more, you can also drop me a message via LinkedIn or via email, and I can give you a list with open source tools.
Okay, perfect. Thank you. So let's take additional questions. The next question is coming up on stage. It's here. What are some example sources for vulnerability scanning? Only a common databases like NVD or these ones, or any zero-day ZTIs or dark web crawling or anything novel?
Um, to be honest, dark web is really, really restricted. So that's why for these kind of databases, it's always a question of ethical questions. So that's why if a really tool want to support it, so that's why for me this question is really, really difficult to answer. So that's why maybe I need to skip this question.
Yeah, no problem. Thank you. Uh, okay, let's go to the next one. This will come on stage. Automotive software supply chains often involve a mix of open source, third party, and proprietary code.
Mhm.
From your perspective, what makes vulnerability management uniquely challenging in this environment compared to other industries?
Yeah, so I think the challenge is that we have various tools, but we don't have a single point where we collect everything. So this is, from my perspective, the mistake is, of course, vulnerability management is always a single solution. But at the end, you can have, or like vulnerabilities can be a lot. It can be also in a VSOC. It can be also like in an, like I mentioned, in binary code. It could be in penetration testing. You will also have vulnerabilities that you need to manage. So you have various names of vulnerabilities, also like building vulnerabilities, like how to protect the doors and don't gain access to everyone. So that's why I think the mistake is the explanation of what we understand about vulnerability management. This is,
Mhm.
I would say, exactly also in different environment. It doesn't matter if this is automotive industry or enterprise, because I saw both and they handle, or there's no big solution to have one tool to handling all the vulnerabilities. Everyone trying to do that, but at the end, I would say the best thing is you have a tool with vulnerabilities. You need, of course, integrate them, best case via APIs, and then make a list of all. And then, of course, the other challenge is who is taking care of which vulnerability, because you can have some vulnerabilities that need to be fixed from the development team, or you have vulnerabilities you can't decide it. It's like completely not in your decision. So that's why this is, I would say, a mistake. The understanding what we understand all about vulnerabilities and what, in our perspective, is a vulnerability management system.
Okay, perfect. Thank you for the detailed explanation. Perfect. Let's go to the next one. This is also another question on the same or similar round. Can the binary scan tools also look for CVEs?
Of course, because the National Vulnerability Database is a mix.
Okay, so this is fine. And then you have the next question coming up. It's quite a big one explanation. I'll try to read out. Have you integrated any methodologies, tools for a comprehensive analysis, which includes the context of both at the same time? I'm assuming some vulnerabilities become more critical with the full context and new attack paths becoming relevant.
Yeah, I tried it because, of course, I use also source code analyzing tools. And I wanted to bring you more examples, but I'm currently facing a little bit the issue that, of course, I need someone who has an SBOM with a related firmware image that I can compare, of course, both results. And this is something I'm currently preparing, but I was not ready for this session, but I'm still interested to exactly find a way to it. If I find a way and have an comparison to it, maybe this is exactly the next talk I will have.
Okay, perfect. So we are looking forward to it. Thank you.
Yeah.
So we still have time. I'll take further questions.
Yes.
I'll take one more. The post-production of ECU, if there is any vulnerability or incident occurs and the vulnerability is in one such SBOM component, how would we ensure fix considering the scenario that I have purchased this SBOM component from my tier 2 supplier?
With supply, yes, of course. This is exactly the point where I also mentioned that you can't fix it, so you can only address it. So that means you can, if your tools already support, download the vulnerability, send it to your third party or a tier 2 supplier and ask for fixing them. And then you see, of course, the statement if they say, we know about the vulnerability, we know it's included in our SBOM, but maybe they made the decision to let it like it is, because there's always a reason why people accept some specific risk. Because it can happen that, for example, if you have a specific vulnerability, for example, in the heating seating, and then, of course, you need to ask yourself, what happened if someone exploit this kind of vulnerabilities? Is it just to making it hotter, or can you also jump from the heating ECU to the infotainment system and then control the car? So that's why it's always interesting to understand why they accept some risk, and this is exactly where WEX helps you to ask or download the vulnerability, send it to your tier supplier, and ask for a statement why they not fix this issue, and then you can write it down to your vulnerability management and say, okay, we accept the risk due to the decision of the tier 2 supplier.
Okay, perfect. Thank you for the answer. We have last minute and last question left. I'll try to put it on the screen. What methods work best for detecting hidden backdoors in vendor supplied firmware?
I would
Not the
say,
known ones, the hidden backdoors. Yeah.
yes. So depending on what you mean with backdoors. Backdoors could be hidden backdoors, like, of course, with binary code analyzing. If you have a good tool, you can also have like reverse engineering included there. And then, of course, like I mentioned, you can see more issues. You can see private information. You can see unwanted software, because I saw in one software some TCP dump and some users that were created, and I was on the first time. So okay, was there a hacker inside and leave his tools in the software, or what was there a reason why someone implement exactly some tools like that and creating some backdoors, but maybe don't be aware that they created backdoors? So that's why with binary code and specific tools, it's able to detect.
Okay, perfect. Thank you for the answer. And
Mhm.
yeah, we are at the end of the session. If there are more questions, if there are any remaining questions unanswered, so I think Irina will be available in the launch. So
Of course.
please go back to the launch and ask the questions. And thank you very, very much, Irina, for the presentation. And it was really a very good presentation and question answer session.
Thank you
Thank
so
you,
much.
everyone. And yeah,
Have
wish
a
you a
nice
nice
day.
day.